Today, students, we are going to be looking at auxiliary views or auxiliary drawings. We have been through a process of exploring orthographic projection. We've looked at lines in projection. We've looked at true shapes. We've looked at true lengths. And this topic just builds on everything that we would have gone through so far with regards to those topics. Critical to the understanding and then the execution of those topics is following the method that you were taught. You will find that you get a little confused if you don't pay attention to following the method, taking one line at a time, marking off the distances that need to be marked off, going back, taking another line like that. If you don't do that and you rush the construction or you rush the process, or you decide that you know what the finished product is supposed to look like without going through the process, you tend to run yourself into a little bit of trouble, and your comprehension then is not as good as it is supposed to be. So trust the process and trust the method that you are required to use for these constructions. Now, we would have had orthographic projection, and you would have remembered looking at the principal planes of projection. So I've represented that here on this page today. This would represent, that I'm scrolling on now, would represent the vertical plane, and this that I'm scrolling on here would represent the horizontal plane. And you know we talked about the hinge line in the center, and then you could unfold them and have the front and plan represented on the drawing page. Now, your end view would normally then be at right angles to those two faces, and you would be able to produce the end view. But what you should note here in this representation is that this plane or this view is no longer at 90 degrees to both faces. So because this plane is now at an angle, what you would produce if you projected a view onto that plane would be slightly different to what you would see under normal circumstances. And that type of view projected on that different plane is referred to as an auxiliary view. You will understand a little bit more as we go along. Now, I would always tell my students that an auxiliary view can be considered to be a flat pictorial drawing. I know that that doesn't make sense at this point in time, but bear in mind, because by the time we've gotten to the end of the exercises for this session, it may make a little bit more sense. A flat three-dimensional drawing. I will represent for you three things today. This is just showing you the layout and the solution being an auxiliary view, and I will do three of these with you, and then you should be in a position where you can attempt and complete one for yourself. So these are the three things that we'll be looking at. I've shown you them complete, and what we will do then is that we will go through the steps to get you to the final product at the end of the day. So this is example number one, and this is representing an auxiliary elevation. Because it is orthographic projection, we know that we can have a auxiliary elevation, or we can have an auxiliary plan. So to get an elevation, it means that you'll be projecting lines from your plan. To get a plan, it means you'll be projecting lines from your elevation. So just bear that in mind as well. But as usual, we will take off some lines, and then we will walk through the process of completing the exercise as we need to. So for this construction then, you are given a hexagonal prism. Remember, a prism is a column. So you have the plan, which will show you a hexagonal shape, and then you would have the faces as represented on this front view here. Now, the XY line is always in, so you can see that XY line in, because a lot of what we do is reference to the XY line, so you have to bear that in mind as well. And you imagine, for me please, that you're located somewhere down here, looking at this drawing, looking at this plan, and seeing what it would look like if you projected it up here. So your viewing area is no longer at right angles to the view, but it is at an angle. In this instance, we're using 45 degrees. So it is at a 45-degree angle, and those are the That's the angle at which you would project your lines to do the construction. So if you're looking from this corner, then you can see one corner, 2, 3, 4 corners of this hexagon. But the corners back here, you wouldn't be able to see if you're looking from down this end. Bear that in mind as well, because then it will have implications for the inclusion of hidden detail. So we have our drawing settled on the page, and we have our XY line. Since we know that we're going at 45 degrees, we know that this line will break at another 45-degree angle. So our XY line is in. That's our reference line. And the first thing that will happen with regards to this construction then is that we will start to project lines for those angles. So 45 degrees, the 4 corners that you can see, those lines go up to your XY line. And once we have those in place, then this is the XY line here. The heights are what we will be required to mark off from that XY line. So in this instance then, we will start to put in the distance that would give us this bottom line right here on the construction. So that line is in, and then we would put in the other distance, which would give us the height, because remember we're taking the heights off of the drawing and all the heights are basically the same. So we can put in then the other distance that will give us the height of the construction. Now all we need to do is start marking off the rest that we need. So we have those heights in. Then the next thing we will do is transfer those distances onto the drawing. So in this case, we should now be able to see these lines, which would be marking the heights in, as we said before. So you have these positions marked off, and to continue with the construction then, we would be able to pull in the other 2 points that we can't see. So those 2 points would now be giving us what should be represented as hidden detail on the drawing when we're done. So once all of these points are in position, then you should be able to show the construction in place like this, where the heights are there. And if you look, you have corner 1 coming here, the second corner going there, third corner across here, fourth corner across here. So those are the faces that you would be able to see. The other 2 corners will be represented as hidden detail. So if I drop in the hidden detail for you, then the construction looks like this. 6 sides represented, but represented in slightly different ways. The width of the sides will vary because of the angle that you're looking at the drawing from. So this is what your final solution would look like, and of course you would do the necessary labeling. So this is construction number 1, and I will just take off all of those extras for you now so that you have the opportunity to see what the drawing looks like again as we had represented initially. So your drawing now, your solution, I mistakenly took out the hidden detail, so let me just put that back in. Your solution then should be represented like this. Drawing number 2 is a representation of an auxiliary plan. We're using the same prism, so I don't have to talk to you about laying out that prism again. But since it is an auxiliary plan, we will be projecting lines from the elevation now, coming down or going up depending on if you're doing first or third angle projection. So these corners will be coming down the page. I would have explained to you that the plan is hexagonal in shape. What you have to bear in mind then, that if the plan is hexagonal, there's a hexagonal shape at the bottom here, and then there's a hexagonal shape at the top here. So let us take off the solution again, and take the opportunity then to produce the remainder of the drawing so that we understand what it is that we are actually generating. So you have front and plan, and the first thing that we will be looking at is starting to project these lines coming across. So once we can drop in the projection lines, and I've gone ahead and marked the height off already, because remember the height then that we want will be the distance from here to here. So I've put in these lines coming right through, and then what will happen is that we will drop in the heights as required. So this is my second hexagon coming across, and then you can see the heights represented on the page. So these heights are from here to the center and then down to here at the bottom. And remember that those heights are marked in relative to the XY line. So you'll be taking those measurements and marking them on the page. So since you can see two hexagons now, the top hexagon and the bottom hexagon being projected, if I look for the points of contact, you would see those points of contact being represented with the outline in this situation like this, and then you would see hidden detail being represented like this. Now because there are all of these lines on the page, you're not seeing clearly the final shape, but if I take out now those lines, then you would have a better opportunity to see what the final product looks like, and you should have no major problems picking it up. So you can see now the two hexagonal shapes being represented. You can see the hidden detail, because if you're looking from the angle up here, then there are portions at the bottom that you can't see. You can see everything at the top, but there are portions at the bottom that you can't see, hence why the hidden detail is included in the drawing down here. So this is an auxiliary plan. The method is the same. It is just that you're pulling off of the opposite view. So if it is a plan, you're pulling off of the elevation and taking the heights off the plan. If it is an elevation, you're pulling off of the plan and taking heights off of the front view. Now we move on then to the final example, and this example, as the solution here will show you, is where we start to see what I was referring to as a three-dimensional, a flat three-dimensional drawing or flat pictorial drawing, because the auxiliary solution here kind of looks like it's an isometric type drawing. So remember, it is still orthographic projection. It is just that because of the orientation and the angle at which we're viewing from, that we end up with a shape that looks like this. So I will quickly remove this stuff from your drawing so that you're able to see us building the drawing as we need to. So take all of that stuff off, and this is what we would be given to start with. You have front view. Now this front view is on an angle, so it's actually on a 30-degree angle, which means that the center of this drawing would be at a 60-degree angle. So what I would have done in order to get this construction up is that I constructed the hexagon on the outside and then projected the corners so that I could get the shape of the front view. Having gotten the shape of the front view, then I project the corners down in the same manner as which I produced the auxiliary before, because remember, this auxiliary would have had a similar look for the view. However, that is now the plan on this construction, but the steps are the same. You pull the corners down, you lay out the center and the two sides, and then you're able to project and complete the hexagonal shapes as I've represented here. Now, as we said before, there are two hexagons. There's a hexagon at the top, there's a hexagon at the bottom. So our process will go something like this. We have our 45-degree angle in already for the XY line. So the first thing that we will do then is pull in the projection lines for our first hexagon. So this is our first hexagon here. These are the projection lines going up to XY. Once we have those in, then we move to our next stage, which will allow us to mark off the heights. Remember that each of these corners comes from up here. So now the height will be transferred to the corresponding line going across here. So this first corner here will come up. That's this first corner marked here that's highlighted. And the height for that will be from the XY line to the corner, top corner on the drawing. And then that is transferred here. And you do that for every single corner that you plot. Now I'm going to take off these lines because it will be a little confusing to show these lines when I'm showing the lines for the bottom as well. So for the projection then of the other face, then the construction looks like this. The other face now is projected up to the XY line, and then the heights for the bottom are then transferred to their corresponding lines. So in this case, if I put in those heights, then you will see those points and you will see the variation in the heights as they are marked on the page. Now I'm going to drop back in the first set of lines as well, so it can look a little confused, but then we will make sense of it at the end. So all of those projection lines now will show you this. You might not see it now, but there are actually two hexagons represented here. So you would then have to plot those two hexagons, connect those corners, and your drawing would then look something like this. So you can see now the hexagon for the bottom, and you can also see the hexagon for the top. Now I'll take off the hexagon, the construction lines for the hexagon at the bottom, leaving in the ones for the top because there are a couple lines missing from the construction. There are some hidden detail lines that would have to be represented, and those hidden detail lines would be shown in position like this. So now the construction is complete. As an orthographic drawing, the auxiliary view is now complete. You can see that it looks kind of like a three-dimensional drawing, and I'll just take off the other construction lines. I'll just put them on. I'll now take off the other construction lines so that you can see what the final product will look like. Remember that the drawings must be labeled and your constructions should follow the steps as set out to allow you to come to your solution. These steps will give you either auxiliary elevations or auxiliary plans, and I can't stress enough how important it is for you to follow the steps as you draw. Thank you very much for your time, and I look forward to bringing you another lesson in the not too distant future.